Hello viewers, in this part today I am going to discuss the systems and methods of irrigation. The methods of irrigation are very important from the point of view of irrigation efficiency. Simply by adopting suitable method, one can increase the irrigation efficiency. Similarly, in our country, different systems of irrigation are being adopted. Irrigation is being applied through canal irrigation system. Irrigation is being applied by diverting the water from the river and then irrigating the crops, and irrigation may be applied by storing the water in ponds and then diverting it for irrigation. By adopting proper system of irrigation and proper method of irrigation, higher efficiencies of irrigation can be achieved. Methods of irrigation. The manner in which irrigation water is applied to the land is commonly referred to as method of irrigation. Applicability of a particular irrigation method depends on several physical, human and economic factors. Important physical factors associated with selection of irrigation method include soils, crops, climate, topography, water quality and availability, depth of water table, field size, maintenance and repairs. Human and economic factors involved are labor and management skills, availability and cost, capital and energy costs in relation to expected returns. So, all these factors decide the method of irrigation. On the basis of these factors can decide the best method of irrigation so that maximum irrigation efficiency and maximum return can be obtained. There are four methods of irrigation, that is surface irrigation, subsurface irrigation, sprinkler irrigation and drip irrigation. Surface irrigation. Surface irrigation is adopted widely in our country. This is the most easy method of irrigation. In the surface methods of irrigation, water is applied directly to the soil surface from a channel located at the upper reach of the field. Water may be distributed to the crops in border strips, check basins or furrows. Two general requirements of prime importance to obtain high efficiency in surface methods of irrigation are properly constructed water distribution systems to provide adequate control of water to the fields and proper land preparation to permit uniform distribution of water over the field. These methods, that is boulder method of irrigation, check basin method of irrigation and furrow method of irrigation are widely adopted. Out of these three methods of irrigation, generally boulder method of irrigation is more common in canal command areas and check basin of irrigation is most common in tube-well command areas. Boulder irrigation. The boulder method of irrigation makes use of parallel ridges to guide a sheet of flowing water as it moves down the slope. The land is divided into a number of long parallel strips called boulders that are separated by low ridges. The boulder strip has little or no cross slope but has a uniform gentle slope in the direction of irrigation. The essential feature of boulder irrigation is to provide an even surface over which the water can flow down the slope with a nearly uniform depth. To achieve higher water use efficiency under boulder system of irrigation, one has to decide or adopt optimum size of the boulder, that is optimum length and width of the boulder. Similarly, the slope of the boulder should be gentle or almost uniform length should be there for irrigating the soil through boulders. This view shows the boulder irrigation. In this, the stream is opened at the head of the boulder and a uniform sheet of water flows throughout the boulder, and when the water flow reaches to the 80% or 90% of the boulder length, then the next boulder is opened. Suitability of boulder irrigation. The boulder method of irrigation is adapted to most soils where depth and topography permit the required land leveling at a reasonable cost and without permanent reduction in soil productivity. It is, however, more suitable to soils having moderately low to moderately high infiltration rates. It is not used in coarse sandy soils that have very high infiltration rates because of the stringent limitations in design. It is also not well suited to soils having a very low infiltration rate. Generally, in medium textured soils and in soil areas where the stream size is higher, under those conditions boulder irrigation is suitable. Advantages. Boulder ridges can be constructed economically with simple farm implements like bullock drawn implement or tractor drawn ridger. Labor requirement in irrigation is greatly reduced as compared to the conventional check basin method of irrigation. Uniform distribution and high water application efficiencies are possible if the system is properly designed. Large irrigation streams can be efficiently used. Operation of the system is simple and easy. Adequate surface drainage is provided if outlets are available. When the stream size is large, under that situation, it is difficult to manage the stream size in check basins. Under this situation, boulder strips are more suitable to irrigate the crops. Moreover, boulder irrigation is suitable for close growing crops. This method of irrigation is not suitable for rice where ponding water is needed. Check basin irrigation. In this method, field is divided into smaller unit areas so that each has a nearly level surface. Bunds or ridges are constructed around the areas forming basins within which the irrigation water can be controlled. The basins are filled to the desired depth and the water is retained until it infiltrates into the soil. When irrigating rice or ponding water for leaching salts from the soil, the depth of water may be maintained for considerable period of time. Since the check basin require more time to infiltrate the water into the root zone, so this method is better for rice cultivation. Moreover, whenever the leaching of salts is required, then check basin method is more suitable in comparison to boulder strips. This is the view of check basin method. Here the check basins are smaller in size and water is ponded in these check basins, which is required to refill the root zone depth up to field capacity. Adaptability of check basin method. Check basin irrigation is suited to smooth, gentle and uniform land slopes and for soils having moderate to slow infiltration rates. Both row crops and close growing crops are adapted to be used with basins. The method is especially adapted to irrigation of grain and fodder crops in heavy soils where water is absorbed very slowly. It is also suitable in very permeable soils which must be covered with water rapidly to prevent excessive deep percolation losses. The method usually results in high water application and distribution efficiencies. This check method of irrigation is simplest, and this is suitable particularly in light textured soils and in rice crop where ponding of water is required. Limitations. The ridges interfere with the movement of animal drawn or tractor drawn implements for interculture or harvesting of crops. Considerable land is occupied by ridges and lateral field channels, and as a result of occupation of this land, the yield is generally reduced, because on ridges the yield performance is less in comparison to flat land. The method impedes surface drainage. Precise land grading and shaping are required. Labor requirements in land preparation and irrigation are much higher. The method is not suitable for irrigated crops which are sensitive to wet soil conditions around the stems of the plants. In case of check basin method, the ponding water remained for more period, so wet conditions persists under these conditions, and the crops which are sensitive to wet conditions, for those crops check basin method of irrigation is not suitable. Furrow irrigation. This method is used in the irrigation of row crops with furrows developed between the crop rows in the planting and cultivating processes. The size and shape of the furrow depends on the crop grown, equipment used, and spacing between crop rows. Water is applied by running small streams in furrows between the crop rows. Water infiltrates into the soil and spreads laterally to irrigate the areas between the furrows. Furrow irrigation can save water to the extent of 18 to 25%. When there is deficiency of water, this method is adopted. This method is more suitable in row crops, especially wide row crops where deep furrows can be formed, and where there is more limitation of irrigation water. In that case, alternate furrow irrigation or skip furrow irrigation may be adopted. For sugarcane, for cotton, especially for BT cotton, this method of irrigation is very effective. Advantages of furrow irrigation. Water in the furrows contacts only 1/2 to 1/5 of the land surface, thereby reducing evaporation losses. Earlier cultivation is possible, which is a distinct advantage in heavy soils. The furrow method may be adapted to use without erosion on a wide range of natural slopes by carrying the furrows across a sloping field rather than down the slope. The method reduces labor requirements in land preparation and irrigation. Compared to check basin method, there is no wastage of land in field ditches. Moreover, there is an additional advantage of furrow irrigation, that the crop is protected by the support of the soil, and the lodging will be less, especially in case of sugarcane. There is less lodging. Moreover, more soil come in contact of the roots, and there will be more uptake of nutrients and water from larger soil volume, and the yield is also enhanced to some extent. Subsurface irrigation. In this method, water is applied below the ground surface by maintaining an artificial water table at some depth depending upon the soil texture and the depth of the plant roots. Water reaches the plant roots through capillary action. Water may be introduced through open ditches or underground pipelines such as tile drains or mold drains. The depth of open ditches or trenches vary from 30 to 100 centimeters and they are spaced about 15 to 30 meters apart. As a result of subsurface irrigation, there is no moisture at the surface of the soil and the evaporation losses are greatly checked. Because of the subsurface irrigation, the weed growth is minimum and hence there is no wastage of water by the growing weeds. Sprinkler irrigation. In the sprinkler method of irrigation, water is sprayed into the air and allowed to fall on the ground surface, somewhat resembling rainfall. The spray is developed by the flow of water under pressure through nozzles. The pressure is usually obtained by pumping. With careful selection of nozzle sizes, operating pressures and sprinkler spacings, the amount of irrigation water required to refill the crop root zone can be applied nearly uniformly at a rate to suit the infiltration rate of the soil, thereby obtaining efficient irrigation. In case of sprinkler, higher water use efficiency may be obtained in comparison to surface method of irrigation. There may be different pattern of sprinkler systems that may be square system, rectangular system or triangular system. The objective is that uniform distribution of water throughout the surface so that there is uniform crop performance throughout the field. Adaptability of the sprinkler irrigation system. Sprinkler irrigation can be used for almost all crops except rice and jute and on almost all the soils. It is not usually suitable in very fine textured soils, that is heavy clay soils, where the infiltration rates are less than about 4 mm per hour. The method is particularly suited to sandy soils that have a high infiltration rate. It is especially suitable for steep slopes or irregular topography. Land leveling is not essential for irrigation with sprinklers, and particularly in western Rajasthan where land is undulated, under those conditions sprinkler irrigation is the boon for the farmers. Moreover, the infiltration rate of western Rajasthan in the soils is quite higher. Under these conditions, surface methods of irrigation are not so successful as sprinkler irrigation is there. Moreover, land leveling is required, that is too expensive, and therefore sprinkler irrigation serve the purpose for irrigating the crops. Soluble fertilizers, herbicides and fungicides can be applied in the irrigation water economically and with little extra equipment. Sprinkler irrigation can be used to protect crops against frost and against high temperatures that reduce the quantity and quality of harvest. Labor costs are usually less than surface methods on soils having a high infiltration rate and on steep and rolling land. More land is available for cropping. Field supply channels and bunds or ridges are not required. So, both water and fertilizers can be applied to the crop by sprinkler system of irrigation, and hence the efficiency of water use as well as fertilizer use can be achieved by adopting sprinkler method of irrigation. Limitations of sprinkler irrigation. Wind distorts sprinkler patterns and cause uneven distribution of water. Ripening soft fruit must be protected from the spray. The water must be clean and free of sand, debris and large amounts of dissolved salts. Power requirements are usually high since sprinklers operate with a water pressure of 0.5 to more than 10 kilograms per square centimeter. Fine texture soils that have a slow infiltration rate cannot be irrigated efficiently in hot windy conditions. And to prevent the effect of wind on sprinkler spray, generally night irrigations are preferred. Night irrigations are more effective in comparison to day irrigations. Both evaporation will be less in night irrigations as well as wind drift will be minimum in night irrigations. So, if the energy is available, night irrigation in sprinkler irrigation is more effective. Drip irrigation. Drip or trickle irrigation is one of the latest methods of irrigation which is becoming increasingly popular in areas with water scarcity and salt problems. It is a method of watering plants frequently and with a volume of water approaching the consumptive use of the plants, thereby minimizing such conventional losses as deep percolation, runoff and soil water evaporation. In this method, irrigation is accomplished by using small diameter plastic lateral lines with devices called emitters or drippers at selected spacings to deliver water to the soil surface near the base of the plants. In fact, drip irrigation is boon to the farmers. The farmers can save water, the farmers can save labor, the farmers can get good harvests, the farmers can get quality harvest by adopting drip system of irrigation. In fact, drip system of irrigation is the system of irrigation for the crop, not for the soil. In this system of irrigation, the entire area of the field is not being wet, only the plant is given water. The system applies water slowly to keep the soil moisture within the desired range for plant growth. For widely spaced crops like fruit trees, the system may be even more economical than sprinklers. There is no need to wet the entire area between tree crops. Like the sprinkler method, drip irrigation permits the application of fertilizers through the system. In comparison to surface irrigation methods and the sprinkler method, drip irrigation can achieve a 90% or more application efficiency. So, in case of drip irrigation, again like sprinkler irrigation, both fertigation and irrigation may be applied, and here application efficiency is to the extent of 90%. Hence, by adopting drip system of irrigation, maximum water use is there. This is the view of drip irrigation in cotton crop. Here the dripple to dripple distance is 30 centimeter and discharge from each dripper is 2 liter per hour. The crop is being grown in paired rows and the distance within the pair from row to row is 60 centimeter and distance between the pair is 120 centimeter. The drip line is placed within the pair and in this way the distance between drip line to drip line is 180 centimeter and in this way the minimum length of the drip lines are required in this system in this particular layout and the cost is minimized. System of irrigation. Available water resources for crop production are rainfall, canal water and groundwater. Based on the source of water, irrigation systems can be classified as reservoir system using surface water, diversion system using surface water, groundwater system using underground water from dug wells or tube wells. Irrigation systems are also classified based on the extent of area irrigated as major irrigation projects having the irrigated area more than 10,000 hectares, medium irrigation projects having the irrigated area 2000 to 10,000 hectares and minor irrigation projects having the area less than 2000 hectares. In this way, these different systems of irrigation are being adopted, whether that is canal system of irrigation or well or to well system of irrigation, or there is diversion. And by diverting the water from the rivers, the irrigation structures are being made. In this part of program, I have discussed the systems and methods of irrigation. The systems of irrigation are canal system of irrigation and well system of irrigation, whereas the methods of irrigation being used by the farmers are surface irrigation, subsurface irrigation, sprinkler system of irrigation and drip system of irrigation. The application efficiency is minimum in surface method of irrigation, whereas it is maximum in drip system of irrigation. Considerable application efficiency may be achieved by adopting pressurized method of irrigation, that is sprinkler irrigation system and drip irrigation system.